Okay, so we're trying to get through 2 lessons today. They're very basic review lessons, things that you had probably at the very beginning of Algebra 1, but we want to make sure that we remember all of those things. These are the objectives. These objectives come from the essential skills in the SOLs, word for word, if there are some. In fact, there's really only one of these that relates to the SOL. It's the first one. These 2 we're going to do because it's just some review that we need to do. So we will review these at the very end of the lesson. You'll see that we did address the things that we said we were going to address. So the first thing we're doing here is just reviewing what we mean by real numbers, right? The sets of numbers. Real numbers, you know, we tend to think of real numbers as, okay, that means they're real, correct? It's actually, you know, more complicated than that. We won't see all of that until we get into the chapter on quadratics. But in any sense, what we call real numbers starts with the smallest set of numbers, and this is a graphic from your book. If you looked in your book, you could see this. If there's any detail here you're not catching. But you see that the natural numbers, also known as the counting numbers, are 1, 2, 3, 4, like that. Okay, starts with 1, and then it's the counting numbers. If you add 0 to that list, then 0, 1, 2, 3, 4 are considered whole numbers. Right? If you add the negative natural numbers to that list, those are called integers. Okay? Now, integer is a word. You know, it may kind of draw a blank if I ask you what's an integer, but I'll tell you for a fact that when you take the SAT, that word is just like right in the middle of the text. I mean, it will say, find an integer that meets this criteria, right? And they expect that you know what they mean by integer. So you definitely want to know what that word means. Okay, so integers are like negative 3, negative 2, negative 1, 0, 1, 2, 3, goes infinitely to positive, big positive numbers and big negative numbers. Rational numbers, again, the word rational is another word that you're kind of expected to know what that means. And every time we bring this up in any class, say, what do we mean by rational? We always draw a blank. Okay, but by rational numbers, we mean, let's see if I got this on, fractions. So a rational number could be 2/3 or 5/4, right? That's a fraction. But even a number like 1 or 2 is a rational number, because if you could write it as a fraction, then it is a rational number. Can you write 2 as a fraction? How could you do that? Just put it over 1, right? So 2 is 2 over 1. So as long as you can write it as a fraction, it's a rational number. When it comes to decimals, and I'm trying to see on this list here, I think this is a 6.1. 6.1 as a decimal is 6 1/10, right? That is a rational number. Decimals, if they terminate, definitely going to be a rational number, because we know what all these places mean to the right of the decimal point. But even if you have something like this number here, this 0.2222, and I imagine they meant to say repeating, 0.2 repeating is also a rational number. As long as it breaks into a pattern, it's a rational number. So the only numbers that are real numbers that are not rational numbers are the decimals that don't terminate and they don't break into a pattern. So something like pi, right? Pi, 3.14156, ... goes on forever, never repeats itself. That is called irrational. There's no way to write that as a fraction. Square roots that you can't simplify, those are irrational numbers. The square root of 2, if you put it in the calculator and see what decimal you get, you're going to see it never breaks into a pattern and it doesn't terminate, it just keeps going.
So would that be square roots of any prime numbers would qualify as being irrational?
Any square root that you cannot simplify will be irrational. Something like the square root of 4, that's not irrational because you can simplify that. That's 2. Right? Or the square root of 9 over 4, 3 halves. right? As long as you can simplify it, then it'll be rational. If you can't simplify it, it will be irrational. And there are ways to prove that, right? There are mathematical proofs to show. For example, the square root of 2 is a fairly easy proof. You can Google it and see it. The square root of 3 is its own separate proof. Square root of 5, I've heard, is pretty complicated, but, it can be shown. In math, in order to show that all unresolved square roots can be simplified, you would have to do a proof. And I'm sure that that's been done. For our purposes, what we're interested in here is if it's a decimal that doesn't terminate and doesn't repeat, then it's irrational. Everything else is a rational number. Everything. Like I say, these are coming from your textbook. Now, how much notes you want to take is up to you. I would just say, don't think that because you took every note that you did your job, right? It's not enough just to have taken every note. Your real job is trying to understand what we're doing. Sometimes there's kind of a balance between taking notes and paying attention to what's going on. I mean, we've all been there. I've been in college classes where I'm sitting there going, I'm writing so fast I don't even know what he's saying. And then you go home and you try to make sense of your notes, like I didn't get it. And you go, maybe I need to have more of a balance between, what needs to be written down and what attention that I'm paying to the guy who's doing this. Now, I'm going to bring up this complex numbers, which is something we will get to when we get into the chapter on quadratics. For this reason, the SOL, actually, the one thing that we're supposed to get out of this first lesson is how to determine what they're calling the field properties of complex numbers. The only thing we have that addresses this are these properties of real numbers that we get in the section 1-2. They're all the same anyways. But the SOL is really specific to what we would call complex numbers. We will introduce those, like I said, in about a month. We'll see what we mean by a complex number. But complex numbers include all the real numbers and include some other numbers which are not real numbers. But we'll get to that. So we're doing this now to address this essential skill, which really has to do with complex numbers, because this is basically the only place that it's addressed for us. And it is the kind of thing, we want to be able to see how review these properties, because we'll be using them all along the way. For example, these are the properties, and you've had these before. For example, we'll skip over the closure for right now. So this commutative property, right, it says A plus B equals B plus A. Is 2 plus 3 equal to 3 plus 2? Yeah, it is. And that's a property. That's called commutative property, right? And commutative property holds for addition and multiplication. 2 times 3 equals 3 times 2, right? So what are they telling you? Order is not important. That's what commutative property says. Now, does commutative property apply to subtraction? Give me an example of where the commutative property would not work for subtraction. Go ahead. Yeah, 5 minus 2 is 3. 2 minus 5 is negative 3. They're not the same thing. So commutative property applies to addition and multiplication. So commutative, you've had. If you didn't remember it, you kind of remember. You did get that somewhere along the way. Associative property means grouping. It doesn't matter like which things you group together. A plus B in parentheses plus C is the same thing as A plus parentheses B plus C, right? That would not change the final answer. That's a property I know you've had before. Identity. For addition, what's the one number you can add that doesn't change the value? 0. That's the additive identity. For a multiplication, what's the one number you multiply by that doesn't change the value? 1. Okay. Now, the inverse property is what do you add to a number to get back to the identity element? Right? What do I add to 2 to get 0? Negative 2. Right? You always add the opposite to get back to the identity element of 0. What do you multiply? What do I multiply by 4 to get 1? Four times what equals 1? Say again? 1/4. What would I multiply times 2/3 to get 1? 3 halves, right? So the multiplicative inverse, also known as the reciprocal, is flip it, right? Flip it. So I know you've had that before. Distributive property, we're actually pretty good. That's the one property I think everybody gets right away, distributive. Remember that. Closure is a property that we don't talk a lot about, but basically means that since we're talking about the properties of real numbers here, that if I add A plus B, they're both real numbers, the result will be a real number. It does not like get you out of that same set of numbers that you're in. I've never seen that tested before, where they ask you something about closure. So here's some examples. Which property does this look like? Negative 2/3 times negative 3 halves is 1. Go back. Which property was it that said when you multiply something by the flip, it's the inverse, right? So that should be a inverse property of multiplication. Which property does this look like? What's changing from the left to the right? Okay, what's changing from this side to this side? You see the parentheses. Yeah, it's just the order, right? Sometimes when you look at that, because of the parentheses, you want to say it's the grouping, but it's not the grouping. It's actually what's inside the parentheses. 3 times 4 has been switched to 4 times 3. Which property says order is not important? You said it close to it. Commutative, right? It's got a T in there. Commutative. Commutative property of multiplication. Right? What property is going on that takes you from here to here? Going home? Okay, thank you. Right. Okay. All right, see you. See you next time. What's going on here? Say again? It's distributive property, right? They multiplied 3G times plus 3H. So that was a distributive. And this one, how could I simplify what's here so that it all equals 3? Which properties could we apply? This is exactly the kind of question you get on the SOLs for this. And this is one, there's only one question on the SOLs that deals with this, for the most part. That's our experience. But it's always something like this, where they're going to give you step by step. Okay, let me show you the steps, and then you tell me what property that I'm using. Okay. A plus negative A plus 3. What property did I use? To go from here to here. What is the difference between these two? It's the order, right? Instead of saying negative 3 plus negative A, and now I'm saying negative A plus 3. So what property is it? What property says order is not important? Commutative, right? So this is a commutative for addition. Okay, now what if I do this? A plus negative A plus 3. What did I just change? From here to here, what changed? What did I move? The parentheses, right, the brackets. What property is it that says the way you group them, it does not matter? Remember, which is the one that said grouping doesn't matter? Associative, right? So we're going to go, that's associative for addition. Okay, now, A plus negative A is 0. What property is that? Not identity. Not yet. Which property is that says that what do you add to get back to the identity element? That is the inverse, right? Additive inverse says if you add the opposite to a number, you get 0. So that is the inverse. And then the last property is 3. Which property says that if you add 0, you get the same thing? That's the identity. Like I said, that's exactly the kind of problem you get on the SOL. And, you know, we only get one. We don't get much practice with this. From now until then, it was one of the most missed questions last year. Okay, now, variables and expressions. That's pretty much the section 1-2, right? That's what we're going to do out of section 1-2. Out of section 1-3, let's review some basic concepts that you've had before. First, what do we mean by a variable? Yeah, usually it's an unknown quantity because we don't know what it is. We represent it with a letter. What's the most common letter that we use? X. Okay. Sometimes we'll use others, but most of the time it's X. A numerical expression is when you have more than one number with some operators, right? Add, subtract, multiply, divide. The one we're interested in here is algebraic expression, right? An algebraic expression is some combination of variables and numbers and operators, like 8x minus 2 plus 5n. That's a variable expression, right? It's an expression because it's a variable expression because of the variables involved. Another way to look at it, which I like myself, I always think in these terms, right? There's 3 mathematical entities that we worry about here. One of them is an expression, right? An expression is something like 2x plus 1. An equation is like 2x plus 1 equals 0. Right? What makes that an equation? It's got an equal sign, right? And then the last thing that we deal with, again, which is mostly the focus of this course, is functions. And a function is something like y equals 2x plus 1. Right? So we're just dealing with the expressions today. But in every chapter, for every new kind of function, quadratic, you know, we will learn how we deal with quadratic expressions. Then we will learn how to solve quadratic equations. Then we will learn how to graph quadratic functions. Right? Every chapter is kind of broken out that way. Yeah. In every chapter, which is a new kind of function, we will do some simplifying of expressions, we will do some solving of equations, and we will do some graphing of functions. So it's both. It's kind of organized around the kinds of functions. But you'll see in every chapter, it just addresses those 3 things for the most part. Now, there's 2 things that you can do with an expression. One of them is, well, okay, before we get to that, since these are expressions and we're supposed to use these to model real-world things, again, this is coming out of your book, saying which one of these expressions would represent 7 fewer than a number t? 7 fewer than t. Madison? Okay, Madison is saying D. Does anybody want a second? Is that 7 fewer than t? Which is the one that's 7 fewer? Okay, what does fewer mean? Less than, right? So it's 7 less than t. You want to start with t and then take away 7. Right, so it should be t minus 7. The answer is C. Okay, how about this one here? Which one of these 4 expressions is 2 times the sum of A and B? Okay, 2 times, right? How do you know that's a times? Right, because of parentheses. We understand parentheses can be one way to represent multiplication. Okay, and what do we mean by the sum? The result of addition, right? So this is 2 times the sum of A plus B, right? Oops. There we go. Okay, this is an example just to show. You start with $20 and save $6 each week. What algebraic expression models the amount that you save? Right? So you have a starting amount plus the amount saved, and what they should say here is per week, and then you're going to multiply that times the number of weeks. So you have to assign variables. You can see here they're saying let W be the number of weeks, 20 is the starting amount, and we're saving $6 per week. So we're going to multiply $6 per week times the number of weeks. I mean, how much would you save in 2 weeks if you're saving $6 per week? 12, right? How many 3 weeks? 18, right? And then whatever that is, you're going to add it to 20. So here's the 20 plus 6W. But you would have to say W means number of weeks if you set that up. I'm going to move on. This is just another example, but we need to keep pressing on here. So once we've got an algebraic expression, there's 2 things that we do with them. One of them is evaluate. Right? Evaluate an algebraic expression means find the value of it. And that generally becomes an exercise in, do you know your order of operations? Right? So remember this, PEMDAS is a way to remember order of operations. What does the P stand for? Okay, parentheses. What does the E? Exponent. What does the M? Multiplication. How about the D? Division. How about the A? Addition. And the S? Subtraction. Okay. So basically, we're supposed to do the operations. As you're looking at your expression, left to right, first you deal with things in parentheses, then you deal with things with exponents, then you deal with multiplication and division as you encounter them from left to right. Right? Then you do the addition and subtraction as you encounter them from left to right. Right? If you encounter a division before a multiplication, you do it. Right? You do it. You don't say, well, I got to do the multiplication first and then come back to the division. These 2 are supposed to be considered together, and these 2 are supposed to be considered together. There was a student that told me over the summer that there's a video that says that PEMDAS is wrong, that it's wrong, and he wanted me to watch it. And so I went, you can Google it. Just Google, PEMDAS is wrong, or go to YouTube, PEMDAS is wrong. And there's a guy, and he does say that. But if you watch what he says the way it's taught is usually wrong, because they don't make that distinction of got to make sure that multiplication and division are considered together and addition, subtraction together. So here's an evaluate. Normally they're going to give you an expression. Here's the expression. And then they're going to give you the values of the variables. Evaluate means plug in for the variables. Right? Plug in for the variables. How will we do that? What, could you get it? Try it. What do you get if you plug in -4 and for A and 5 for B? Try it. Yeah, try it. Got a -20. Anybody else? What'd you get? 7. Got two different answers. Who wants to confirm one or the other? -20 or 7? Got a 7? Here's the answer. 7. Right? The answer is 7. Now, this is an example of something that I'm going to show you now. I'm not showing this to my Algebra 2 trig class, but I'm going to show it to you because the fact is we make so many mistakes by trying to simplify or evaluate because of order of operations, especially when there's negative numbers involved, when there's squaring going on. We just make a lot of mistakes. There is a way to do this with your calculator that will eliminate, the calculator will take care of all of this for you. And I want to show you this. I mean, this is something we'll use along the way, and it is the thing that raised our SOL pass rate 20 percentage points in 1 year. This exact thing I'm going to show you. Let me see if I got. So I'll do it here. Get rid of that. So the first thing we want to do is we want to store values for A and B. So you should have your calculator out, and this is what it looks like. I've got an emulator up here too. First, here's something for you to know, because I don't want you like going through the whole class not knowing some very basic stuff about the calculator. How do you clear the memory of the calculator? Yeah. Second, if you notice above the plus sign right there, it says mem. So if you do second plus, it brings up that menu, right? And the 7 is reset. And 1 is all RAM, which means memory. And 2 is reset. So that gets rid of everything. So everybody's starting at the same place. Now, notice that you have alpha keys. You got see the alpha button right there? And then above all the keys underneath, there's a letter. And if you want to like type the letter in the calculator, you got to do alpha and then that key. So in this problem, we need to be able to do A and B. Right? So the A is above the math key and the B is above the one to the right of that. You see that? Yeah. Sure. You mean what we're doing here? You'll see. You'll see. Okay. Here's how you would store it. Since we want A to equal -4, here's how you make that happen, right? First, do the -4. -4. So you should have that on the screen. And now, see that button right there? The second to the bottom on the left side says STO. That means store. So you say store, and that's the value of A. So we want to go alpha A. So it looks like -4 arrow A. When you hit enter, it stored A as -4. Okay, what does B equal? 5. So do the same thing for B. 5 store, and now we do alpha B. I could do that. Now we're going to do that. We're going to put that expression just exactly like you see it there. I mean, you guys are good at texting, right? Just do it with your calculator now. We're going to go 7 parentheses A plus 4. So that's alpha A plus 4. n parenthesis plus 3b minus 8. And when you hit enter, it's going to evaluate it with those values of a and b. And it's going to do all the order of operations. And the answer is 7. So if you remember that, you'll never make a mistake with this. You can even do the quadratic formula with this. As long as you could type it in, the negative b plus or minus square root of b squared minus 4ac all over 2a, right? And that's given to you anyways. So yeah, you could do so much with this. So that's one thing that we do with an expression is we evaluate. Right? Given values for the variables, we just see what it would equal. And I'm skipping over a couple of these because we're just going to run out of time. The next thing, first, here's an expression. Negative 4 ax plus 7w minus 6. It's important for us to understand in an expression what we mean by a term. A term in an expression, terms are separated by pluses and minuses for subtraction. So in this expression right here, there's how many terms? 1, 2, 3, right? They're separated by a plus and a minus. And that minus is not like a negative 6, like it's multiplying times negative 6. It is minus 6. So when it's being subtracted by additions and subtractions, then those are 1, 2, 3 terms. The number, if there's a number like negative 4 or 7 in front of the variable, that is called a coefficient. Right? That's a math word. We use it. We'll use it, not trying to confuse you. It's just the word you're supposed to use when you're talking about the number in front of the variable, coefficient. Right? That's this one right there. And when you have a term that doesn't have a variable in it, that's a constant because it doesn't change. It's always negative 6. It's not going to, no matter what I plug in for x or w, it doesn't matter. The negative 6 stays the same. So a constant term is that. So the last thing that we do with expressions, we simplify. And by simplify, at least at this point in the course, simplify means combine like terms. What do we mean by like terms? Variables are the same, powers are the same, right? So for example here, they've already given it, right? 3x squared plus 5x squared, those are like terms because they both have x squared, right? This 9y to the third z and negative 4y to the third z, those are like terms. They have the same variables raised to the same powers, right? Now, how is it that you combine like terms? How would I add 3x squared plus 5x squared? Okay? You keep the x squared the same, right? It's like saying 3 oranges plus 5 oranges is 8 oranges. It doesn't change the oranges, right? Still oranges. So this is 3 plus 5 times x squared, which is 8x squared. Right? How many y to the third z's do we have? Since it's 9y to the third z minus 4y to the third z. 5, right? 9 minus 4, 5. So we're doing these two, right, will be 9 minus 4 times y to the third z, which is 5 y to the third z. And then what about this 2yz? Stays the same. There was nothing to combine with. So the answer will be 8x squared plus 5y to the third z plus 2yz. So again, for expressions, we do two things. We evaluate by plugging in values. We simplify by combining like terms. So let's do this one. Simplify by combining like terms. Which are the like terms? Okay, so let's see. These are like terms, and these are like terms. Okay, how many x squareds do you have? How many? 7x squared minus 4x squared. Right, 7x squared minus 4x squared is 3x squared. How about 3y squared plus 2y squared? 5y squared. Right, how about that one? Say again? You got to distribute first, right? You got to use the properties before you can do this. So what are you distribute? Well, this is pretty easy, right? 2 times k, 2 times negative 4m. What are you distributing here? The negative, right? It's like a negative 1 time. So you're going to have to multiply like that, and like that, and like that. Yeah, negative 3k minus m, 2k minus 8m. Okay, once you've got that, you can combine like terms. Which are the like terms? The k's. Negative 3 plus 2 is negative 1, right? Notice they didn't write the 1. They just put the negative. It's assumed that there's a 1 there. And negative m minus 8m is negative 1 minus 8, negative 9. And yeah, go ahead. Yeah, try this one here. Try the hard one. Yeah, try the B. What was the first step? Okay. What? Distribute the negative. What did you get? Negative 8a minus 3b. Okay. Then what? 10 times 2a. 10 times negative 5b. Negative 50. Okay. Which are the like terms? Okay. These are like terms, and these are like terms. How many a's do you have? 12. Negative 8 plus 20 is 12. And how many b's do you have? Negative 53. Okay. So that's what we did, right? We went over the properties, reminded ourselves on the properties. We know that they're about real numbers, but they really are supposed to be about more than just real numbers. We learned how to simplify algebraic expressions, which is mostly combining like terms. We learned how to evaluate algebraic expressions, which is plug in a value for the variables. That's it. The homework is coming from those two sections. Now, if I was you, if you want to do the evaluate with the calculator, in 5 minutes you could probably get all the evaluates done by storing values and just typing it in. Yeah. I think that is 16 to 19.